Hello, welcome once more to Prepclass online class and in physics, and my name is Tutor Dami. Now in this video I shall be simplifying physics past question, Jamb past question 2019, question number 46 to 50. And don't forget that if you really enjoyed this video, if it was helpful to you, you can tell your friends about it, and you can click on the like button in online there, so that you can get more content from us that will help you in your journey of understanding physics. Now we are part of the help team that really want to help you to be masters of physics. Now let's take out number 46. Which of the following particles may be emitted in a process of natural radioactivity? Now, when we talk about radioactivity, what particles are emitted? Do you have any idea? Natural radioactivity. Now, is it alpha particle or beta, or alpha and X-ray, or beta and X-ray, or gamma? Y? That Y symbol means gamma and X-ray. What do you think might be the answer? This is very easy. Now, actually, natural radioactivity has to do with three particles: the alpha ray, the beta ray, and the gamma ray. And of course, we know that the alpha ray is positively charged and it contains proton and neutron, right? But the beta ray is negatively charged and it has no mass. Okay, that means it is made up of electrons only. While the gamma ray is chargeless, it has no charge. Okay, that means it is electromagnetic. But actually, take a look at it. Now, it is natural radioactivity is made up of alpha, beta, and gamma. And the natural radioactivity from my picture can be found in nature. Radioactivity found in the ray of the sun. Radioactivity is found in plants, it's found in soil and rock, it's found in our body. That's human body. It's found. This is just natural radioactivity. Okay, then you must know that these are all rays. We can have alpha ray, beta ray, and gamma ray, but we can't have one ray. And that ray that is the problem of this question, that is the problem, is X-ray. X-ray has no place with radioactivity in the natural form. So X-ray is a poison to the question. So any of the option with X-ray is poisoned already. So the A has alpha and beta, which is the correct answer. Actually, gamma can also be with them, but they don't alpha and beta, they are still correct. But the B is poisoned by the X-ray. Alpha and X-ray. X-ray has poisoned the question. The option B. Then the option C is beta and X-ray. X-ray poisoned it again. Then D is gamma and X-ray. X-ray poisoned the gamma. So the only unpoisoned option is option A, and that makes option A the correct answer to number 46. Now let's take out number 47 quickly. Which of the situation is photoelectric effect employed? Now, have you heard about photoelectric effect? Now, actually, photoelectric effect was first explained by Albert Einstein. Do you know that? Now, photoelectric effect also help you to open and close doors on their own automatically. Some of us must have been to an eatery where the door opened on its own. That only was made possible by the photoelectric effect. Okay, now, in which of the following is the photoelectric effect employed or used? One, we have automatic device for switching on light. Like if light goes off, like if NEPA take light, there are some places, there are some companies that the light comes up automatically on its own. That is the function, another function of photoelectric effect. It always has to do with automatic work, okay? But it has to do with some things and not some things. So let's take it out. Number 2, we have automatic doors. I said that before. So it opens, okay? Then number 3, we have automatic device for switching on air conditioner. Is that true? Then automatic voltage stabilization. Is that true? Now actually, photoelectric effect is only, let's take a look at it now. In this one, all I just explained here was to broaden your scope of photoelectric effect, what it means. But you must know that my answer is only in option 1 and 2. Okay, before I explain that, I'll just want to pick my answer. My answer actually is automatic device for switching on light. It helps to switch on light on its own. And automatic doors in departmental store. It does not work for automatic device for switching on AC, air conditioner. It is not true. That's not the function of photoelectric effect. Then number 4, please. Automatic voltage stabilization. That is not also true. Photoelectric effect is not used for that. That's not what Einstein said. So that those 2, 3, and 4 are wrong. Why 1 and 2 are my answer, making option D the correct answer. Okay, but let's explain photoelectric effect a little, as it was taught to us by Albert Einstein. Now, photoelectric effect, photo means light, electric means, current, that's charge. Now, when light shine, it is all about the photoelectric effect refers to what happens when electrons are emitted from a material that has absorbed electromagnetic radiation. It has to do with when light shine on a light sensitive material, like what we have there. You can see my ray, ultraviolet rays coming in as a light. It shines on this material, on this negative material called cathode. That material is light sensitive. So, and when it perceives the light, what does it do? It produces electrons. And when light shines on this thing, on this cathode, it produces electrons, and those electrons flow like current. They flow like a wire. Those electrons are conductors. So now, this is my circuit. Now look at this thing. This entire thing is a circuit. But this circuit stops here. It is not closing because this place is a gap. There's a space here. That means if you plug a lamp here, if this G is a lamp, the lamp will not power on because the circuit is not complete. The wire has been broken here. It stopped here. It's from here to here. But how can you complete this wire? By shining light on this light sensitive cathode, it will produce electron on its own. Okay, those electrons act like wire and they help to complete the circuit. So you can close circuit or complete circuit and then there will be light. You can complete circuit without using anything. You can use air, that's electron, in things that you cannot see, invisible things, to complete a circuit. That means what I'm saying is that you can use electrons. We can't see electrons, but you can use them as electric, like electric wire, to complete a circuit and to produce current. So that means what we are saying is that you can see the door opening in an eatery, but what opened that door is an electron, right? And that electron cannot be seen, but the electron acts as a wire that helps to connect to something. Okay, when you are coming to the door, you block the light. So when you block the light, the light sensitive stuff notice you and then complete the circuit by making what electrons to flow, and that electron flow complete the circuit and the door responds. Okay, so that's what we call photoelectric effect. Application is, it can be used for electric panels to also open doors and so on and so forth. So those are the applications. It can be used for electric panels to open doors and so on and so forth. And that is simply my answer. My answer is option 1 and 2. Okay, so let's see number 48. Which of the following radiation has the longest wavelength? Which one has the longest? Is it gamma, radio, infrared, ray? That should be infrared ray. Then we have X-ray. Which one is the longest? Let's take a look at it now. You can only remember that all these guys that they mentioned in the option, they are all called electromagnetic wave. Now, all the electromagnetic waves are given by this formula, Revox G. No, R means radio wave, infrared is I, then visible light is V, ultraviolet ray is U, X is X-ray, and G is gamma. Now, the wavelength, that means the one that is longest, flows from radio wave. That means the longest is radio, while gamma is the shortest. Okay, so that means the longest is radio, the less long is infrared, the invisible light, but the least is gamma. So when we talk about length, it is radio wave. But when we talk about frequency, it is gamma ray. And the frequency comes from gamma, comes to X-ray, then down to ultraviolet ray. Then the least frequency is radio wave. So the question says which one has the longest wavelength? It is simply radio wave. And that is the answer. Don't forget this chart. It will help you as you go on in physics. Whenever you have questions on ultraviolet ray, this is what to use. So the answer is therefore radio wave, and that is it. Now let's look at number 49. Number 49 says, in which of the following field is radioisotope not used? Now when we talk about radioisotope, what are we talking about? Now let's take a little study on radio. You know the word isotope must be close. You must have an idea from chemistry. Isotope are just elements with the same what? They have the same atomic number but different mass number. Okay, so they are actually the same type of element but with different mass number. But radioisotope, radioisotope has to do actually with radioactivity. But let's take a look at it now. Let's take a little study of it. Now, radioactive isotope is also called radioisotope or radionuclide or radioactive nuclide. Any of several species of the same chemical element with different mass, I said that before, whose nuclei are unstable and dissipate excess energy by spontaneous emitting radiation in the form of alpha, beta, and gamma ray. They are actually radioisotope. Okay, so we have alpha, beta, and gamma. They are actually radioisotope, and they are also under natural radioactivity. So they are also natural radioactive emissions. Okay, so those are the three guys. Now let's take a look at it. Now we have, it is used in medicine to arrest the growth of cancer. So it is used medically. Number two, in industry, radioisotopes of various kinds are used for measuring the thickness of metal or plastic sheet. Now, which one is not? So it is used in the medical field. It is also used in the industry to find the thickness of metal or plastic, right? Now, which one is wrong? Now, it is used in the A said medicine, B said oil industry, C said agriculture, D said weather forecast. Now, it can actually be used in the industry of agriculture and for oil because they are all under industry. Now, because you can also deal with different of these industrial materials can also be used in the agriculture because agriculture supply industrial materials. Okay, but weather forecast has nothing to do with the use of radioisotope. So radioisotope can't be used for weather forecast, and that is just the simple answer. It is not used for weather forecast, but it is used for medicine and for industrial work that has to do with metals and plastic thickness measuring. So that's just the answer. It is not used for weather forecast, and that is the criminal we were looking for, and that is D as the answer. It is not being used. Now let's take out number 50 now. Wow. Number 50 said not accessible. That means that the question is not in a past question. So this is going to be where we will stop. Don't forget, if you really enjoyed this video, to click on the like button so that we can get more content that will help you in future time. Until we see you next time, take care of yourself and bye for now.